Okay, I'm back. I'll finish up our experiment. So we got to do the paper again, of course. It's in the name of science. This piece is a little bigger, so I'll be a little more safe. And yeah, that's quick. It's pretty amazing. The white piece of paper turns to black, giving off smoke. Those are our basic observations. Let me take the 1 or 2 centimeter wood flint. We've actually done this before for hydrogen tests, but again, in the name of science, we got to do it again for a different purpose, and that's to actually just look at it and watch the wood. And so that is just turns black real quick, glowing, goes out, simple, also produces smoke. Okay, let's try this stretched out piece of steel wool. Steel wool again is pure iron, so I'm gonna burn iron, and yeah, this is awesome. Kind of like a little fireworks show, tiny little fireworks show. Little balls of flame traveling up and down the strands of iron. I think I got it all. A little bit of smoke, but I'm wondering if actually this smoke is just some sort of heat, because certainly less smoke than the paper and the wood. So that's an interesting difference to think about. But again, same thing. The steel wool was kind of grayish before, now it's really a lot darker, more blackish. So, okay, those are the results. I'll be back in a second. We'll see if we can make sense of these results and really dig into actually what fire is, one of the greatest mysteries in all of the history of science. Okay, let's see if we can make sense of this phenomenon of fire. And the best we can do is really make an induction, make inductions. And an induction is a scientific statement that we believe is true, that we hope stands the test of time, that we hope holds water as we proceed through the course. And if we do an experiment or make an observation which seems to contradict our induction, well, then our induction was wrong. And that's the best we can do. 2 scientists in the 1600s that boldly made an induction were Johann Becher and Stahl George Ernst. This was in the 1660s, and I say boldly because it was kind of established dogma, established thought that fire was one of the 4 elements. The Greek theory of matter was that there's only 4 things in the universe: fire, water, earth, and air. And so they said maybe fire is not exactly an element. Maybe it's a temporary thing that only accompanies chemical changes. So they came up with a new theory. And the theory, they came up with a new element. And what they called it was phlogiston. It's a famous idea, famous theory in chemistry, the idea of phlogiston. And what they said is some elements that burn more must have more phlogiston, and some elements that burn less don't have much phlogiston in it. So whatever phlogiston is, it's something that allows something to burn. It creates that fire. So wood, for example, has phlogiston because wood burns, but it has less phlogiston than paper because when you're done burning it, there's still more stuff left in the wood. This, which is now cool, this little wooden splint has a lot of black char left over, but that paper is completely gone. So paper is almost all phlogiston, and wood has some phlogiston. So this was the theory of phlogiston. One other point I want to make. Also, where's the phlogiston go if it's no longer in your material? So where's the phlogiston in wood go? Where's the phlogiston in paper go? Well, it goes into the air. So you have phlogisticated. It's a word they came up with. You have phlogisticated the air. So there's phlogiston in the air. So this was the theory. This was their induction. And we'll see if this holds water throughout the remainder of this course. And if it doesn't, we better come up with one that does.